Okay, guys, I hope you are able to see the screen. I'm going to start the session now. Let's, uh, let's try to cover this virtual networking part is taking too long, so there are too many topics in it. And just a quick recap, what we did last week. We actually discussed about OSI layers briefly because this takes these are the fundamentals you have to understand, right? These are very basics and fundamentals to understand what technologies we are going to cover in this networking domain. Okay, so that's this was covered last week. I have uploaded the video. I've given the brief explanation on OSI model, how different layers work and different technologies fit into those layers. We have once again, I have a message from someone. All right, very good. So we discussed briefly about the Azure load balancers, right? So we have seen that there are two types of load balancers. We can, I mean, the product itself on Azure is same. It really matters how you deploy when you deploy the load balancer, in which what is its position in the network. Based on that, you will decide whether it is a public load balancer or the private load balancer. Okay. So if you see the screen here, the diagram which I'm showing here. Sorry, let me use a pointer here. 1 second. Right. So this you see this component. This component represents a load balancer, and the basic functionality of the load balancer is about distributing the load and making sure that your service is available. So there are two. It serves two purposes. One is high availability. It makes sure that your service, the website which you are hosting, like for example here in this screenshot in the slide, mywebsite.com. So without load balancer, what will happen is you will be hosting this site directly on the virtual machine and publishing it to the internet, right? Now, what happens if that web server is down? You are running a single web server. So if you want to make this website highly available, you would like to use some mechanism, some technology which can make that possible. So you will probably have another web server, two web servers deployed, but still only having these two web servers will not make your site highly available because you need some technology which can combine those two web servers and make it as one. So that you can do with the help of load balancing, load balancers. Uh, you can deploy a public the load balancer here in your network, which will receive the traffic for your website, mywebsite.com, and that will the public IP for your website will be assigned to the load balancer. And this load balancer will have your web servers as backend. So it has the algorithm, load balancing algorithm, based on which it will see route the traffic to particular web server. So it will make sure that the both the web servers are utilized, and in case of a failure of one of the web server, your website will still work. So it will the moment it sees that this server is down, one of the web server, load balancer will detect that and it will stop sending traffic to that particular server, and it only sends the traffic to the server which is available. So that makes your website highly available. Now, when you talk about website, there are different websites you can have. You can have a static website wherein you have static content and only it will be only running on the web server itself. You might also have you might when the website is providing more services and it's providing the complex services, it will also have a backend deployed, right? So if you look at the website web architecture of the websites or web apps, it will have the front end, it will have application servers and the backend database servers. So you also call it as a multi-tier architecture. So in that case, you might also require those backend servers to be load balanced, and to make it high, to make your website highly available end to end. So you should in this what this diagram shows you is that your web servers are highly available with the help of public load balancer, and you can also deploy an internal load balancer to balance the traffic and make sure that your site is highly available. So internal load balancer can distribute the load among the application servers and the database servers, right? So this makes your solution, your site or the service highly available. So that's what Azure provides you, uh, load balancer, public load balancer, and the internal load balancers. So we have discussed this. We'll see with the lab how we can achieve this load balancing functionality, right? Then yeah, this is what it tells you pretty much everything what I've explained you. Internal load balancer has no public IP. That is the only difference. It's the same product on Azure. If you don't assign a public IP address to that load balancer, it becomes a internal load balancer. It is accessible only inside your virtual network. So you can see the placement of the internal load balancer. This is your internal load balancer. So your VMs are the front ends, and your SQL servers are the backend servers. Right? Traffic comes from internal applications, background application servers. Use case is basically for backend application servers, database servers, and internal API servers. Example, now it's not the users who connect directly to the backend servers. It will be the application servers. In this example, the virtual machines, which are in the front, which are considered as the front end servers, those servers will connect to the internal IP, the load balancer internal IP. Okay, and the load balancer will connect to the database servers in the backend. Right, there are different sizes. Again, for these load balancers available on Azure, load balancer SKU in Azure. I've explained you earlier. It's like a product which you're selling on e-commerce site, right? Every product which you're selling on e-commerce site will have an SKU. That means the size, specification, and the specs of the product. Similarly, Microsoft also has have their products available on Azure portal and the platform. And you can see here, or you can see while creating the load balancer, you can choose the type, public or internal, right? So this really matters where you're deploying this load balancer. And these are the features you have. There is standard load balancer. The type is internal or public, and backend can be IP based or link based. Health probes. We'll see what are these, what exactly this means. I'll explain you on the whiteboard how this actually works. And you can create the load balancer rules on load balancer, defines how traffic from front-end IP goes to the backend. So the client who's accessing your website will actually see the load balancer IP, front-end IP address, public or private load balancer. Then it will have the load balancer balancing rules. Defines how traffic from front-end IP or port goes to the backend VMs, controls which protocols and ports are used. TCP or UDP. Supports options like session, stickiness, and floating IP. We have also seen this in the previous session. If you want, you can watch that video and refresh your knowledge on this slides which I have already discussed. I don't want to discuss this again. So session stickiness, what does it mean? Is used when an application is stateful and requires all requests from a client to be consistently routed to the same backend instance. You can see that in this picture, there's one client machine. It is having multiple connections to your website. Basically, user is connecting to your website over the internet, and it is coming to the load balancer. Load balancer, uh, by its nature, it will balance the load. So one connection is sending to one of the virtual machine VM1. Second one is sending to the second VM. Third one is sending to the third VM, and it does load balancing based on these five tuple hash. So basically, it maintains these sessions. The connection one which you see here is basically a session established between your client machine and the web server. So based on the source IP address, source port, destination IP address, destination port, and the protocol. So each connection will have all these five tuple hash, which load balancer builds. So that's how it keeps track of the connections what you have established with the web server. Okay. Next, what we have? Okay, next we are going to the Azure application gateway. So we stopped here last time in the last session. So let's do a whiteboarding on Azure load balancing, or we'll start with the lab directly. Yeah, we will do both. The lab, what we are going to do is about the load balancer. I'll explain you on the whiteboard what exactly we are going to deploy and manage on Azure, how we are going to do that. Right. So here we are trying to target and cover these topics today. Load balancer, application gateway, traffic manager, and Azure front door. These are all different types of load balancers available on Azure, and each has okay, whiteboard is loading. Meanwhile, I'll also bring up the lab article from Microsoft Learn. See, Microsoft Learn is a very nice portal for learning. You have every topic which you want to learn on Microsoft products, and it has very good, nice labs also available with the detailed instructions on how you build and manage those technologies which Microsoft is offering. So in this example, what we are going to do is create a public load balancer to load balance VMs using the Azure portal, right? So look at the architecture here. It explains you what exactly you'll be doing in this exercise. So again, as we did last time, I told you when you're practicing these labs, there are many topics which will be you will be refreshed. The topics will be refreshed, and those labs, like for example, we did the Azure Bastion lab before. So again, the same thing will be repeated here, and your knowledge will be reinforced on how and where you use the Azure Bastion. So the setup is very simple. You need to understand this. So what we are going to do in this lab is basically we are going to create load balancer, public load balancer basically, and we are going to balance the load with two virtual machines, which will be running our web server, right? And we are also having a test VM that is for our administration purpose, I guess. So yeah, we'll see that. We'll see what are the topics we are covering in this. Okay, let me just draw this. What are we going to do in this lab? Get started with Azure Load Balancer by using Azure Portal. To create a public load balancer for a backend pool with two virtual machines, right? Other resources include Azure Bastion, NAT gateway, a virtual network, and the required subnets. We have not seen what is the NAT gateway. We are deploying that as part of this lab, but I'll explain you what and where we have to use it, right? So let's do this lab together, and at the same time, I will also explain the same this on the whiteboard. And remember, whatever labs you are creating, you can delete the resource group later on in order to stop billing on your accounts. user lab. Right. So for creating the NAT gateway, it says in this section you create a NAT gateway for okay. Why we are using the NAT gateway? For outbound internet access for resources in virtual networks, right? For other options for outbound rules, check out NAT SNAT for outbound connection. So do we need NAT gateway? Now the question is to you, do we need a NAT gateway for accessing internet from our virtual machines? Can anyone answer me that? If you are able to answer whatever we have learned so far, we have done many labs, right? We've seen how to access internet from the virtual machines on Azure. So my question is, do we really need a NAT gateway for internet access from Azure? Yes or no? Just simple answer.
Yes, sir.
Yes, yes.
We need the NAT gateway. Did you ever configure the NAT gateway in our previous labs? I didn't remember doing it. I don't know if you guys have done it. We have not done it. we we,
We are
we
not.
have not
Previous,
created.
previous we
Yes,
didn't do the NAT kit.
yes. NAT gateway. This is the first time we are touching this topic. NAT gateway. We have not done this before. You know that when you create the virtual machine, by default, that virtual machine will have access to the internet. And we have tested this many times without even discussing or talking about the NAT gateway. Right now, why we are deploying this NAT gateway, we'll see that when we discuss the topic about the NAT in the next slides. But right now, since we have not covered it, I'm just going to run through the labs and show you what how we create the NAT gateway. It's mainly about controlling internet access. So we have not done that so far. So with this one, we are just going to create an NAT gateway now. And that's part of the lab. That's the reason we are doing it.
Sir, it is the same thing the last time we practiced like service endpoint. We are controlling the internet inbound and outbound
No,
rules. Same, no, not like
no,
that.
we didn't use the
Mm.
NAT gateway there. There's a different purpose for NAT gateway. I'll explain you when we discuss the topic, right? So right now, just follow the steps what I'm doing. That's why I asked you the question particularly. For internet access, you don't really need an NAT gateway on Azure deployed. By default, your virtual machine, all the virtual machines which you build, it will have internet access by default without doing anything. So now let's do this now. I'm going to create the NAT gateway. Create. Okay. So this might be a little confusing for you, but I just want you to see this because what we are trying to understand in this lab is the load balancer. That's our main topic. In the basics tab, it says, okay, we are going to use the subscription and we'll use one resource group which we can delete later on. So in this exercise, it's going to create a resource group with this name. So it will be easier for you to locate it and delete. Select subscription resource group. For every resource on Azure which you create, you must select the subscription and resource group. Without that, you can't create any resource, right? So LB NAT gateway, that's the name I'm able to give. It's going to be in ECUS by default. Okay, this ECUS2 here. Let's deploy it in ECUS. And availability zone, none, no zone. Idle timeout is 15 minutes. I'll explain you this when we discuss the NAT gateway, what we are doing here. And here it says, okay, select the outbound IP. Next. So we are going to create a new public IP address. Public IP address, enter the name NAT gateway public IP. We select okay. Review and create it. So that's the first thing we are creating here without even creating our virtual network. We are just creating a NAT gateway. Now we are going to go ahead with create a virtual network and a bastion host. Let's create this one. I'm sure you know what is the use of bastion host. If you want to tell what it is, otherwise it's up to you. So let's create a virtual network parallelly now. So I'll explain you same thing what we are doing here, like last time we did. Do not just follow the steps what I'm doing. Also understand what how it actually fits into your Azure Virtual Network, Azure platform. So now we are going to create a virtual network. Before this, what we did, we created a NAT gateway, right? Let me just draw something for it. NAT gateway, and it has a public IP address. How it is represented in the diagram, I'm not sure. I'm just putting some diagram here for that. Now we are going to create a virtual network. And in this virtual network, we are going to create something called Bastion host, right? Bastion. Okay, I have not heard from anyone what is the Bastion host used for. Anyone? I'm sure Khaja and Junaid knows this. In the last session, they were available and they have answered this question. If you are able to answer, if you are in a space where you can talk, it's you're free to talk. Otherwise, it's up to you. Virtual network. I'm going to create a virtual network now. And these are the properties we are going to use. We are going to put this in the same resource group, and the name we are going to give LBVNet. Okay, you can see this subscription is already selected. Resource group is correct, and this is the name of the virtual network. It should be in the same region actually. ECS. Okay, we are going to go to the security tab now. Next. And here I'm sure we're going to enable the Bastion. Under the Bastion, enter the following information. Enable Azure Bastion. We're enabling it. And this is the name of the Bastion host we're going to provide. LB Bastion. And Azure Bastion public IP address. we are going to create a new public IP for Azure Bastion. There is the option. Create public IP address. I'm going very slow, guys, for you to understand what we are doing. So it is having this name and the IP address. Okay, next we are going to go to the next tab, IP address tab. See, create virtual network. We have seen creating virtual network with basic settings earlier. In the last session, we have seen this. We are touching almost all the tabs here in virtual network creation. In security, we have activated the Bastion host for the virtual network. And now in IP addressing, we are going to choose what IP range we need for this virtual network. And we are going to choose the default one, /16. Okay, and select the default subnet. And this has a default subnet created. You can see that uh, since we enabled the Azure Bastion, it is going to create a Bastion subnet as well, right? And that's the range. So we are going to put this information. You're able to see the screen, right? Creating the virtual network. Right. So we are going to create a virtual network with this range /16, and we are creating a Bastion network, and that's actually 10.0.1.0/26. So, okay. And this Bastion host also has a public IP assigned, right? So we have created a public IP for this. So this is what we have done so far. We have chosen the IP range for the virtual network itself. We have Azure Bastion subnet created, and we have a default subnet. So what are we going to do with the default subnet? Let's see. And we are going to name the default subnet as backend subnet. Right. Save this. And it is having the default IP addresses already. And in the subnet, we are going to activate the NAT gateway as well. Let's see this. Right. In this subnet, now this is an extra step we are doing now. We have seen how to create the subnets before, but we have not seen how to activate the NAT gateway on that subnet. So we are going to create a NAT gateway. Now we already have created a NAT gateway. We are just going to use the NAT gateway here. So before creating the virtual network, we have created this, right? You can see that NAT gateway here. Okay, right. So we have done this. We're going to save this now. So let me now put this information also on the whiteboard so that you understand what we have done so far. So now we have created a subnet for these servers with the name backend. Right. This subnet has the IP range 10.0.0.0/24. And on this subnet, we have also created something called NAT gateway. We activate it. The NAT gateway is activated on subnet level. NAT gateway. Okay. This is what we have done. The page. We complete the NAT gateway. Okay, we are here. So we did this two things. Now we are going to continue. Let me close the unwanted tabs. It is creating confusion for me. So the tabs which are not required, I will just close them off like this one. So we should have only two tabs for this. Seconds. I'll close this as well. So we have our lab article and we have our actual lab. Right. Let's continue with this. Right. So we have created a virtual network and Bastion host. Right. Now we are going to go ahead and create the load balancer. Now nobody has explained me or answered me what the Bastion host is used for. Just going to explain that briefly. Let's say you have the virtual machines here in this subnet. Okay, we have PM1. We are going to deploy this as part of the exercise anyway. These are the two VMs I have. This is a Windows server. For example, we are going to deploy both as Windows server. I'm just explaining you here for the purpose of understanding the Bastion host. So I'm going to have a virtual machine with Windows operating system and a virtual machine with Linux operating system. Now you, as an Azure administrator, you have built this network, virtual network. You have built all these virtual machines. Now, while creating the virtual machine, you know that you can activate the public access, right? So when you're creating the virtual machine, for example, this one, you have to enable the public IP address on this. And we have seen that Microsoft does not really recommend, or this is not, it's not a good security practice, which Microsoft also recommends you not to activate. What will happen if you activate the public IP? Your VM will be directly exposed to the internet. With this public IP address,
So we are
whatever,
using Bastion for not to access the internet. Is it so?
sorry,
Bastion, we are using Bastion not to access the direct internet from the Bastion is used for creating the public IP address we are giving to the VM, not the
exactly.
direct
So
internet.
yes, yes. So what we are doing is basically uh, in order to reduce the public exposure of our virtual machines, our servers. Virtual machine is nothing but your server, right? It's running very your critical applications and having data stored on that server. Now, when you don't have the public IP assigned to this VM, there is no way you can log into this VM and manage this VM, right? This is nothing but a server. How will you manage it? You're building a virtual machine with Windows operating system or Linux operating system for a purpose. You want to install an application on it, you want to configure some uh, or deploy some infrastructure component or something. So that's the purpose you're building the virtual machine. Now you build the virtual machine, your virtual machine is running, but you can't really, if you do not enable the public IP, you can't access it. How do you access the virtual machine if it is a Windows server? How do you manage it remotely? You use something called RDP protocol. We have seen that in previous labs. If it is a Linux server, you use something called
SSH.
SSH client. That's how you access. Now, in order to access that, your VM, because this is the VM on Azure cloud, it has to has a public IP address available. Then only you can access it from internet, from anywhere in the globe. Now, if you're removing that public IP, there's no way you can RDP or SSH to your server. So the alternative what Microsoft gives you is the Bastion host.
Bastion.
So you configure the Bastion host, and that Bastion host will have a public IP address assigned. And when you, as an administrator, want to manage this virtual machine through Azure portal, you use something called Bastion host. So we have seen how we do that. This is done through Azure portal. We'll see that again. Okay, we use the portal and we choose the virtual machine which you want to connect. Let's say VM1. So if it is a Windows server, it will ask you to choose the appropriate protocol or the tool which you want to use to connect to it. If it is a Windows server, I will use RDP. So when I choose RDP, what will Bastion host will do? It will initiate a connection, RDP connection to this virtual machine internally. This is all happening internally on the Azure network. So your VM is not directly exposed to the internet. The Bastion host, your connection is going through Bastion host. So you as an administrator, you can log in and manage that virtual machine through the Bastion host. That's why we are deploying the Bastion host. So you'll see from now on with all the exercises what we do, we'll be always creating a Bastion host. So I don't know to repeat this exercise or explanation again. So you should understand why we are creating and building a Bastion host. It's like it functions as in real time scenarios. I can relate this to the jump server concept. Jump server. It is called jump server. I'll explain you. So you will have one server which is protected, and through that server you will basically jump to other servers. So that's why it's called a jump server. So that's the concept on if you relate it to the on-prem scenarios. Okay. So now we what we have done so far, we have deployed, we have created a virtual machine. Sorry, we have not done the virtual machines yet. We have created the virtual network. We have created an ad gateway. We have created Bastion host. We have created a backend subnet. So let's do the next things. Next, we are going to deploy a load balancer. We have not done this part yet. Okay. So create a load balancer. We did not complete this. So we will create. Okay. The virtual machine is being created. We can parallelly do our lab for the load balancer. So in this section, you create a zone redundant load balancer that load balances virtual machines. With zone redundancy, one or more availability zones can fail, and the data path survives as long as the zone is in as long as one zone is in the region remains healthy. So we'll see. We are just creating a zone redundant load balancer here. During the creation of the load balancer, you configure front-end IP address, backend pool, inbound load balancing rules, and the health flow. These are the important. This is the important configuration for any load balancer. So what is the front-end IP? Now I'll explain you here. So if you look at the diagram, see this one. So you see here the load balancer is having an IP address, which is the public IP address side. So we are going to create now the load balancer and also configure those settings, right? Let me go through these steps, then we'll see on the whiteboard again how it is placed and where it will be located. So why we are discussing load balancing? Because it's part of the syllabus. So when you're talking about AZ 104, which is Azure Admin Associate, and AZ 305, which is Azure Architect, these are the topics which are included in both the certifications. And admin part, it is mostly about the administration of that particular service or the product. And in the AZ 305, it's more about designing that particular solution. So there are different ways you can deploy these load balancers. As we have seen in the initial slide, there are different load balancer options available. So when you're designing as an Azure architect, you have to use these different technologies to deliver the uh, one of the best architecture for your organization or the customer, right? Now let's do this. Create a load balancer. The load balancer, let's create. So while you're creating the load balancer, you also have two options here. Standard load balancer with a small description. What does it do? Distribute traffic to backend resources. It does not look at this particularly. It does not say backend virtual machines because it's not only the virtual machines which can run your web server. Azure has alternative options. You can even have the containers running the web server of the web application. So it says backend resources. It can be virtual machines or it can be the web applications. We'll be seeing that in the next sessions, how we can create the web apps without even using the virtual machines, how you can hold the website on Azure. So that's one of the option. You have the gateway load balancer, direct traffic to network virtual appliances. We're not discussing that right now in this scenario in this discussion because this is mostly about this is covered in what the networking track certification, which is AZ 107. So let's focus in this here on the standard one. We are going to create the standard load balancer. I'm trying to explain you the concept and the technology. And when you relate this to any other cloud service provider, you can easily understand what this technology does and how it functions. Okay, create load balancer. So here we are at the load balancer configuration. Resource group, we are going to use this resource group so that we can easily wipe out all the configurations after the lab. Region is going to be ECUS, yes, and the name of this load balancer, we are going to name it as load balancer. Okay, and we are going to use the standard one, not the gateway one, and the type is going to be public. Since this is going to be facing the internet and it will be receiving the traffic for the website which you are going to host, it will be a public load balancer and leave the default as regional. So we're going to make this load balancer as a regional one. We also have an option of global, which we are not discussing right now here. Now the next option is front-end IP configuration. So this is what we're going to do now. Next, add a front-end IP configuration, and we're going to give it a name again. So you can see that every resource which you create on Azure has to be named, and there is again a separate guidelines from Microsoft on the naming convention, so that it will be easier for you to manage the resources on Azure. So I'm going to give it a name LB frontend as per the lab, and it's going to be IPv4 address. In the IP version, you have two options: IPv4, IPv6, and then IP type. You have IP address, IP prefix. Uh, so select IP address, IP type. You're going to go with the IP type. What is the type you're using here? Create new public IP address. Okay. IP address. We are going to go with the IP address, and we are creating a public IP address for this load balancer. Okay, we have some more options here. Select zone redundant and availability zone. In the IP address which we created, what did we choose? As by default zone redundant. That's fine. So but we select that. Okay. That's Sebastian IP address. It did not create it. So we'll create it again. It'll be front end. That's the name. It's going to be IPv4. It's going to be IP address, and we are going to now create the IP address, public IP address, and it's going to have this name. create new. Okay, and this we're going to select zone redundant and availability zone. Oh, where is it gone? Okay, zone redundant and save it. And save this IP. All right, so we got that. Leave default for routing option. Yes, we did that. Save. We are back here. Now select backend pool. Next step is selecting the backend pool. In the backend pool, add a backup backend pool. Going to create, click here, add backend pool. And I think yes, we have to create a backend pool as well here. Still should be too busy creating the resources. Let's run through the steps. So step 17, we're going to name the backend pool, and we're going to select the virtual network also where will our backend pool will be available. And the backend pool. Okay, the name of the backend pool is this, and it has an option here to choose the virtual network. What we are doing now, we're creating a backend pool on the LB, and we are saying that our backend servers, the virtual machines, are in this particular subnet. So the subnet which we have created, if you see here, oops, sorry, whiteboard, yeah. So this backend subnet which we have created, this will host our backend servers. For LB in LB load balancer terminology, these virtual machines which will be running the web servers in this subnet will be called as backend servers or backend pool of the servers. So we are making our service highly available, so that backend pool must have more than one server in it, right? So let's continue these steps. So we selected the virtual network where our backend pool will be available. Select the IP address for the backend pool configuration. Okay, select the IP address for backend pool configuration, and what else we have to save it. Okay, we saved it. Now next, we are defining the inbound rules. Now, what are these rules? Under load balancing rules in the inbound rule tab, add a load balancing rule. Add a load balancing rule. Okay. And in this, we are going to create a rule for this. So the name of the rule is HTTP rule, IP version 4 or IP6. Here we're going to deal with IPv4 only. Frontend IP address. Okay, that's fine. We have already selected that. And now backend IP pool. We created just in the next last step. Protocol is going to be TCP. Port is going to be 80. You should be knowing the default port for HTTP service is 80, and the backend front end and the backend would be 80. So what we're doing here, I'll explain you on the whiteboard right in a minute, so you'll understand it much more better. Health probe, we are going to create a new health probe. Create new. The name of the health probe is this. select HTTP in the protocol, leave the rest default. Okay, create this. Protocol is going to be TCP port 80, interval second 5, and just save it. Right. So health probe is created. Session persistence. This is the sticky session which we discussed earlier. We're not doing activating that, and we are putting the idle time of 15 minutes. Okay, enable TCP reset, select the checkbox. Enable floating IP, leave unchecked. Okay, TCP reset, we are checking it. This we are leaving it as is, and click save. Okay, we are still creating the load balancer. This is all the configuration which belongs to load balancer. Select review and create, and that's it. So what have we done in this load balancer configuration? We have done the basic configuration. We have created a front-end IP. We have created backend pool, and we have created a health rule. Uh, this is the rule which checks the health of the servers. Uh, let it create. Meanwhile, I'll explain you on the whiteboard what we have done so far. Okay, so let's go back to the whiteboard. So what have we done now? I have created the load balancer. Sorry. Let's say this is a load balancer block. For this load balancer, we have created a public IP address. Okay, we have created the which is nothing but a front end IP. Okay, and we have created a backend pool. So that backend pool is nothing but is connecting to this virtual network. Sorry, I'm not able to write here. Let me reduce the size of this network. Backend pool. So we created backend pool, and that backend pool, we still don't have the virtual machines in the backend pool. We have just configured a backend pool saying that this backend pool will be under this particular subnet, right? And we have created one health rule. What is the health rule? We are checking the health of the backend servers on port 80. These are the web servers which will be running on the backend. So this is what we have done so far. That is created. The load balancer is done. Let's continue the remaining labs. And here we are going to create the actual virtual machines. Now this might not be the sequence you'll be following in the production environment, because in production you might already have the virtual machines first deployed in virtual network, and then you'll be deploying the load balancer and configuring the load balancer. All right. So let's create the virtual machines. So in this section, you create two VMs, LBVM1 and LBVM2, in two different roles. We're going to create the VMs in different roles, zone 1 and zone 2. These VMs are added to the backend pool of the load balancer that was created earlier. So we are going to have these two virtual machines as the backend pool, right? Let's create the virtual machines quickly. We have seen this many times, so I'm not going to explain you the creation of the virtual machines again. I'll just run through it. You just follow and see what we're doing. Okay, this is going to be LB1. So where is our load, the resource group? This is the resource group, virtual machine. This is the name. ACS was fine. Availability zone. We're going to choose availability zone and zone one. Right, this is going to be a zone in zone one. What are we doing here? We are creating virtual machines in availability set, right? We're creating two virtual machines. One will be deployed in zone one. That means, what is the zone here? What do you mean by zone? In the East US region, there are multiple zones available. You can see here there is zone 1, 2, and 3. Each zone represents a data center, right? If you remember the initial discussions and the basics, what we have learned in the fundamentals, a zone is nothing but a data center, right? So we are going to place this virtual machine, the first one, in zone 1. That means in data center 1, and it's going to be standard. Security type standard image. We are going to run 2022 as per the article. It is quite old now. We don't have 2022 listed here. So we are going to just choose the 2025. Let's choose any one of this. Azure Edition. We'll go with Azure Edition. Okay. Azure Spot instance, leave default. Spot instance, that's default. We're not doing anything. Okay, choose the VM size. We are going to leave it as default. I'm going to create the username password. Azure admin. That will be my administrator account. Right? Public endpoint done. See, this is what I was explaining you. If you do not activate the public endpoint, that means this virtual machine which you create, you can, there are only two options you have to access the virtual machine through RDP. One is using the Bastion host. The other one is using, if you are having your on-prem setup, and from you have a connectivity between the on-prem setup and the Azure cloud. You have a hybrid setup from Azure, and you are an administrator who sits in on-prem scenario. From there, you can access that virtual machine. You can do the RDP and access and manage that virtual machine. That's one way. Or there's a third alternative, which we have not discussed yet, which we'll be seeing later, and that is with the help of VPN. We have not seen how we can enable and activate the VPN services. If you have a VPN service activated, you can also use VPN and connect to your Azure virtual machine and manage it. We'll be seeing that later. So we are going to the networking tab now. Okay. Select next disk. Next networking. Okay. So we are going to go to the next networking. And in the networking, we are going to select the virtual network. That's important, right? So this is our virtual network, and we are going to place this virtual machine in our backend subnet, right? So this is going to be one of the backend server. Public IP none. Public IP is going to be none. We're not assigning any public IP to the virtual machine. And we are going to the advanced tab. Advanced tab. Where is advanced here? Advanced here. Okay. Network next security group. Click advanced. Configure network security group. Skip this setting until the rest of the settings are completed. Okay. So we're just selecting advanced and skipping these settings. Delete NIC when VM is deleted. Leave the default. Okay. We're leaving everything by default for now. Okay. Load balancing. There's a load balancing option here. Load balancing option, select Azure Load Balancer. So we are going to select Azure Load Balancer. right? And here it gives you the load balancer which we have created. So it shows you the load balancer which we created earlier, and select a backend pool, and it's going to choose that as backend. This VM is going to be part of that backend pool. Configure network security group. Now we are going to create a network security group here. Now, anyone tell me what is the use of network security group? We have discussed this many times.
Sir, it's inbound, outbound rules, sir. It will
Rules.
Yeah, network security group
traffic
is
rules.
used to control the traffic flow between the virtual machines, right? Or inside and outside network of your Azure virtual network. So with the help of network security rules, you can you can manage the traffic, you can control the traffic flow. Now we're going to create a new security group. I'll clearly this one. I'll put everything on the whiteboard so that you can see clearly how each of this component is fitting and where it is deployed. Okay, and we are creating inbound rules here. Inbound rule, and the service is HTTP. Source is any. What is this? Add an inbound rule in service, select HTTP. Here, HTTP, right? See, the moment you select this service HTTP, it selects because the default port number for HTTP service is port 80, and which is grayed out. You can't really modify that because that's the default port number for this service. So this rule we are going to create, and priority is going to be 100, and we are changing the priority now and naming this rule energy rule, LB energy rule, and click OK. So you can see here, this rule says source any, source port any, destination any, service HTTP, and port 80, and we are going to allow this. Default is allow, priority is 100, and this is the name. Okay, this also I'll explain you on the whiteboard what it is. Review and create it. Now we are done with this network security group. We are going to review and create this virtual machine. We have to do the same for one more virtual machine. Once this is done, okay, and run through the same steps for the second VM. We're just going to name it differently, and it's going to be in zone 2, and it's going to use the same network security group what we have created right now. So let's create that also quickly. To machines. It's going to be part of the same resource group. LBV2. East US is the region. We are going to select the zone, availability zone, and it's going to be in zone 2, not in both the zones, in zone 2. Okay, and it's going to be standard security type, and the Windows version is Azure edition. Okay, and same size, whatever default size is, and this is the admin account. Right, we are not enabling the public endpoint. We are not assigning the public IP to the virtual machine. We're going to the next step. Disk, we are not changing anything. Networking, what are we doing in the networking? This is going to be part of backend subnet. It's already selected, and this will have a WIP. Is it going to have the public IP? No, it is not going to have any public IP, but it's going to have this network security group assigned. which we have created, and that is LB NSG. That's the name of the network security group, and it's going to be part of the load balancer and the load balancer which we have created, and the backend tool which we have created. Right. So that's all we have done for the VM1. Let's review and create it. Then I'll go to the whiteboard and explain you what we have done. Okay. So that will be our second virtual machine created. So now I'm going to the whiteboard again. So what we have done is we created the virtual machine 1, virtual machine 2, and we configure them as part of this backend pool. So they are both now part of the load balancer configuration, and they are in the backend pool, right? And we have also created the network security group, right? What does that network security group say? NSG. And we have created one inbound rule. That rule says source any, right? Source protocol or port number any, star also you can reprint it as star. Service is HTTP, and the default port for the HTTP is port 80. And we are allowing this service. Okay, this is the rule which is applied on both the virtual machines. So this energy rule is applied on VM1 and VM2. So what will happen? When this load balancer, why we have done this rule, I'll explain you. Remember, on the load balancer, we have created a health probe, right? This is our load balancer. Okay, LB. We created a health rule, check availability of the backend servers, the backend pool, VM1 and VM2. So it is checking on port 80, right? It is continuously checking the virtual machines. VM1, VM2. So this for activating, for making the sure that your LB is able to reach these servers. This LB will actually keep checking the health of this virtual machines on port 80. That will make sure that the site is available, highly available, right? This is what we have done so far. Okay, so let's go ahead with this remaining lab. Install IAS. Now what we are going to do now is actually setting up the web server on our virtual machine. So let's go to our virtual machines. Do you have any doubts in the lab setup so far? I want you to have a clear understanding of this, what we have done so far and what we are going to do next. So why we are doing all of this? Well, the moment you have the IAS web server installed, it will be clear for you why we are doing all this. Okay, we have got the virtual machines ready. Right, LB1 and LBV1 and V2. Now we are going to connect to the VM1. How do we connect to the VM1? As you know, we have disabled the public access to the virtual machine. The only option is that connect via Bastion, which functions as a jump server. So since this is a virtual Windows Server machine, a Windows Server virtual machine, We are going to use username password. So that my password which I have given, and we are going to connect this. Okay, that's our VM1, and we can also access the VM2 at the same time. That's VM2. Let's go back to the lab. Okay, so what are we doing in this lab? Basically, we are installing the IA server, which is the web server available on Windows Server operating system. And we are removing the default IIS start.html file, which is the default web page. The moment you install the IIS web server, add a new IIS start.html file that displays the name of the virtual machine. Okay, I'll explain you why we are doing this. So let's install the IIS service. We're going to the command, PowerShell command. Accept this. Okay, accept. I'm doing this action on both the virtual machines. The same thing we have to do. We have to install web server on both the servers, VM1 and VM2. So these both VMs are actually part of the backend pool of our web. In real time scenario, you will have your website content loaded on both the virtual machines, and you have to make sure that the contents are same. Because when the users are accessing the site, your website abc.com, the request will land on the load balancer, and load balancer might connect you to VM1 or VM2. So your users should not have different experience every time they're connected to different virtual machines. So in order to do that, you have to make sure as an administrator, as a web admin, or website administrator or the developer, the content on both the servers are maintained, and they are exactly the same. So let's do this now. I'm installing. I'm going to follow the script. So this PowerShell script is what it is doing is installing the Windows feature by the name web server, and it will include all the tools, management tools for it. And it is also going to remove this default web page, which the IIS creates, and it is adding actually a new file with a different content. So it says hello world from the computer name. So with this, with the help of this, what will happen is you will know where your request is landed on VM1 or VM2. So let's see, solve this, and do the same here. So it might take few seconds for doing this. Right. So after this, what we are doing, we are closing the Bastion connection. Okay, we are doing the same on VM2. We have done this already. And after that, we are going to test the access to our website. VM2 seems to be faster than VM1, though they have the same configuration and same resources. And this is what I was saying, Sudhini, when you have the internet, the VM created by default, you will have internet access on the virtual machine. Start browsing. Let's see. Right? You're able to access the internet without any problem. This will be the default behavior on the virtual machines on Azure. You don't need any other configuration for that. It's taking a while. So while this is happening, so let's go back to the virtual machines here on the lab whiteboard. What are we doing here now? On VM1 and VM2, since these are Windows servers, we are installing IIS service, which is a web server, Windows web server, right? And we are creating a home page with a message VM1. Similarly, here we are doing the same. That is going to be having the home page with the name VM2. It shows the moment you browse that website, it will show you the machine name because it's fetching that information from your computer name. Okay, so on VM2, you can see the web server is configured. Now I should be able to browse this web server locally. So if I go http// localhost, it's not working on localhost. Let's see the IS service. That's the default site. See, what does it say? Hello world from VM2. It is showing you the virtual machine name. And this one is still going on. Okay, let's go back here and the whiteboard. So now what will happen is the moment we have this virtual machines for web servers up and running, you as a user, let's say you are an internet user and you want to access this website. If we have hosted on our virtual network and we are using the load balancer. So load balancer IP, for example, this I've got the IP address 172.3.4.5, whatever it is. Just for explanation, I'm giving this. So this is the public IP address assigned to your load balancer. In the real-time scenario, what you would do is the users will not access your website with the IP address. And you can't tell the whole world what is the IP address of the website, right? Doesn't really make sense. So you will use your DNS and you will map your website www.abc.com to the public IP address, which is assigned to your load balancer front-end IP, right? This will be the scenario. So now, as a user, when I browse .abc.com, I will get the IP address from the DNS service on the internet. This all happens on the internet, right? So your machine will get the IP address. Will know, okay, this is the IP address of abc.com, and it will try establishing a connection over the internet. The connection will land here, and your backend, load balancer will look into the configuration in the backend pool. It will see that, okay, I have two virtual machines running. It can connect you to any one virtual machine. So in this example, since we have deployed web server with a static web page, which shows the actual name of the virtual machine. So every time your request lands, it can go to virtual machine 1 or virtual machine 2, any one of this. So that's what we have to see. Now, since we don't have the DNS configuration, we are going to use the public IP assigned to our load balancer to access it. So let's go back to the virtual machine 1. Okay, it is ready now almost. Let's see if the web server is running locally. It's my default website. I'll try to browse and see if it is working or not. Okay, it is working. So you're getting the web page, hello world, VM1, right? So this is your default page. Where is this page? Actually, this is on your web server, for web server folder. By default, it will be, you can see here, inetpub root, and this is a file which we are referring to. We can even go and edit that file. We'll go. So you can see that message here. Yeah, let's say I'm just adding that. So here, if you go to this, and right. So just to show you, so you can browse again and see. Okay, VM2. VM1. Right. Let's now check the load balancing if it is happening or not. So now for me as an internet user, what do I need? I need to know the IP address of the load balancer, right? Because we don't have the DNS configuration. We have not registered any domain name and mapped public IP address. So let's go to the load balancer and see what is our public IP address. Okay, so this is your front end IP address. You can see this is my public IP. Now, as a user, I have to see, right? Now, what do you mean? What do you actually make out from this message? You should understand that your request has landed on virtual machine 2. Okay, you have two virtual machines in your backend pool, VM and VM2. So this is good. Now it is not necessary that my connection will always go to this. I will close this one and open again, and let's see where does it go this time. Since we are only it's just one user, it might end up anywhere on the same virtual machine. We'll see that. Now it is going to the VM1. Do you see this, how the load balancer is working? Are you guys clear? Any questions here, guys? I just want to hear from you.
Questions from my side.
Clear, clear.
Right? So this is how, see this. I just want you to learn the concept here. how the load balancing functions. The lab which I have taken you through is to show you the configuration, how what you're doing on the in deploying the web server, making sure that your web server is highly available. Let's try something that's not in the lab. What we can do is now we'll shut down one of the virtual machine and see how the load balancer will behave in that scenario. So we have tested the load balancer. We are going to go ahead with the cleanup rules. Before that, we'll just test. We'll bring down one of the virtual machine, shut it down. I'll just stop this. Hold the option here. Stop the virtual machine. Yes. Okay. Now my virtual machine should be stopped. All right. So VM2 is now deallocating. That means it is off. I should not be able to access it anymore. You can see the network connection to the server is lost. So now I have only one virtual machine running. Let's see as a user, what will be the impact for me? I'm trying to access the web server. Now you can see that the connection is always going to the virtual machine one. Let's close this one and open again. Okay. And you can see that your connection will always land on VM1. So that's the advantage of having the load balancer. And as I explained you can deploy the load balancer in different scenarios. If you have seen let's go back to these to the slides. So you can do, see, it's again, I always emphasize that you should do these labs yourselves and try to do uh, the similar way as I'm showing you. Draw your setup, you know, that will give you the clarity on what exactly you're doing. And so instead of following the steps blindly and just seeing the result at the end. So that really will help you in understanding and having the concepts clear. Now, next thing what we are going to discuss is the Azure application gateway. Now, we'll see how it is different from the load balancer, the major difference. This is also one of the type of load balancer, but here, if you can see, this has some application level intelligence. It works on application layers. Application gateway manages and filters HTTP and HTTPS traffic. So this is purely for HTTP and HTTPS traffic, right? The load balancer, what we have seen, load balancer mainly deals with layer 4 and layer 3, TCP protocol and UDP protocol. That's what it deals with. But here, when we talk about Azure application gateway, it will have the intelligence on application level and it will do the load balancing based on applications. Right. So what is the difference here? Application gateway manages and filters HTTP, HTTPS traffic, routes traffic based on URL paths or host names. Support VMSS. What is VMSS? Anyone? What does VMSS stand here? Stands for virtual machine skill set. I hope you remember we have seen what creating virtual machine skill set, which is done for scaling the resources, right? Like so, application gateway supports VMSS as a backend. You can also have an app service. The same scenario what we have just seen now, creating the virtual machine, installing the web server. Instead of doing all of that with the virtual machines, what you can do is you can straight away go ahead and make use of app service. You can have the without virtual machines, you can even run your web server with the app service. So and we'll be seeing this in the next classes, how we can build the web server without having even deployed the virtual machines and on-prem servers as backends. So Azure Application Gateway can have uh, these as backend servers. It can be load balancing the traffic, application traffic to the virtual machine scale set, application service. It can be as considered as a backend, and even on your on-prem servers. So you can use Azure Application Gateway on Azure. And if you have the hybrid connectivity, you can have your backend servers deployed on your on-prem network and use that as a backend server. And works at layer 7 for intelligent routing. And it can also do SSL offload and security. Now, what is SSL offload? Does anyone know? You know HTTPS site, right? You have a website now. Almost all the web traffic over the internet is HTTPS. So why it is called HTTPS? It is a secure website. All the sites are running on HTTPS. It's for the security purpose, right? When you talk about HTTP, running your web server on HTTP is the data transfer which happens over the network will be in plain text. And in order to secure your information being transferred over that channel, now almost all the websites they run on HTTPS protocol, right? HTTPS, that means they are encrypted, and you have to use something called SSL certificates for encrypting the traffic. So when your web application or the site is encrypted, what will happen when let's say in the load balancer scenario, okay, sharing this whiteboard right now, right? So let's say your site is HTTPS secure website, which will have a certificate attached to it. So when the request comes, if you are using the load balancer, it'll be or application gateway, Azure application gateway, which will be a front end for your web services, and the backend could be virtual machine, virtual machine scale set, can be a web app service, and you can even have the backend as regular servers in your on-prem scenario, on-prem network. Right. So when the request comes here for this site, when it lands on your load balancer or the application gateway, it can do the SSL offload. That means SSL offload. That means it removes the certificate. It offloads this connection, and when it does the internal connection, this is public, right? It's over the internet, and this connection is internal. So this connection, it can be on port 80, which is the plain HTTP connection. So it will remove the certificate. It will establish a plain text connection, HTTP connection to your backend servers. So this functionality is called SSL offload. So it will remove the certificate from your connection when it comes to the front end. It does the SSL offload and it establishes a connection with HTTP connection internally to your backend servers. Right, that's called SSL offloading. Let's go back to our slides. Right, so we'll see now how we can do the load balancing with the help of application gateway. So we have here, let me see. Right. So there's a little more explanation about the application gateway. Application gateway has routing. There are two routing options in application gateway. Path-based routing. That means if you see here, path-based routing routes traffic based on URL path. Example. Now your web server might contain different contents, right? It can be an API call. It can be a call request for the images on your website. It can have a different path and the videos. So when you load a website, for example, abc.com, now that website might have different configuration. So for images, it might redirect you to some other server internally. For videos, it might redirect to some other server. So when the connection lands on your application gateway, you can actually do the routing based on the path. So if you are having the pool of servers, for example, in this scenario, you are seeing that there's a website called contoso.com, and this is the application gateway, which is having and you should also know that the application gateway, this is the product from Microsoft. Application gateway is a load balancer again, layer 7 load balancer, you can say. It says layer 7 load balancer. It it will also have a functionality of WAF. What is WAF? We've not touched base this one right until now. WAF stands for Web Application Firewall. So your L7 load balancer also has a security built in with it. Web Application Firewall. It has the Web Application Firewall integrated. So this is your application gateway in a whole. Like when the connection lands on the application gateway, it can do the routing based on the content. So if you are maintaining different servers in the backend, a pool of servers for having all your images which are there on the site are stored on this pool of servers. The videos which you are publishing through your website are stored on a different server. So you can do the routing on the application gateway for this particular web scenario, right? Then you also have site-based routing. So this is mainly useful in multi-site routing, routes traffic based on the host name or domain name. So let's say here you have in this scenario you're hosting two websites on your server, contoso.com and fabricom.com, and you have different set of backend pools. You can see in the first example, your website or web server is running on virtual machines. There are three virtual machines. And in the second example, you're running the website directly on web app. As I told you, you don't really need to deploy the virtual machine in order to run the web server. You can use the application server, web app service from Microsoft Azure and run your websites directly on web app services. So your backend can be virtual machines or it can be web app services. So with the help of application gateway, again, if you are having multiple websites, you can route the traffic to specific set of backend pools for specific website. So that's the those are the advanced features which you get with application gateway product. So in the load balancer, the only the basic load balancer, you won't get this functionality because that load balancer doesn't understand the application gateway details. Ideal for hosting multiple apps behind one gateway. So this is the example. Then we have something called traffic manager, which also functions. It's not a load balancer of kind, but we'll see. What we'll do is we'll see if there's any lab for the application gateway. Then we'll touch this one. So after this, we have Azure front door service, and then there's a quick comparison. So you can see the quick comparison here. There's a traffic manager which works on DNS level, and in data path that means it means the service actually receives, inspects, and can manipulate the traffic. In case of this load balancer technologies, which you see here, Azure Load Balancer, which works on L4, layer 4, application gateway, which works on L7, front door service also works on layer 7. It can actually, what the load balancer is doing, their load balancer is able to receive the connection. It is able to change, decide, take the decision based on the rules, and it can also inspect the traffic. So it can understand the whole application and the data flow. Whereas with Traffic Manager, it doesn't really understand the data or the application being transferred. It's a different purpose. We'll see in which scenario we use this. But here, these are the three relevant services: Azure Load Balancer, Application Gateway, which we have just seen, and Front Door. Now, Front Door is almost similar to Application Gateway. The only difference which you see here is the Application Gateway is deployed regionally for load balancing, whereas front door is the global is used for global load balancing. That means your backend pool can be different regions. You can have your backend pool deployed in different regions. We'll see that in the whiteboard after this. Then CDN, Azure firewalls. We'll just touch base these different technologies because we can't go in detail of each of this. There's WAF, there's DDoS attack, Azure Bastion we have already seen. Just in time access, we'll see what it is. We'll see what network watcher is. IP flow verified diagnostics. Okay. So we'll see all of this briefly because most of these topics are actually part of AZ 104, which is Azure networking certification. So here we'll just deal with mainly with the load balancers in this discussions. Now let's see if you have any lab for application gateway. And I see there are two labs available. Let's see what we have. Okay, direct web traffic with Azure Application Gateway. So what are we doing here? We are deploying application gateway and then again we are load balancing the traffic. Let's see what exactly. Okay, it's a similar exercise. We already have two virtual machines, right? So we can do this quickly. What is changing is this, just the VM, that's the load balancer technology. So Azure Load Balancer, we are deploying the application gateway. So let's run through this quickly. What is the second one? Create an application gateway with path-based routing. Okay, so this is path-based routing. So in this, we'll create an application gateway, create virtual machines for backend servers, create backend pool, create a backend listener, and path-based routing. Okay, so probably we'll do this one because this is a little different than what the load balancer does. So here we are doing based on the path. So based on different content, we are going to redirect the traffic to different servers. So let's see this lab, quickly. So we can probably make use of the existing lab setup what we have and just add to it. Just get rid of this, which is not required. I hope you guys are following with me. If you have any doubts, any questions, please feel free. If there is anything which is not clear, this is the time to ask the questions. All right. So we'll get rid of this. Keep this configuration. Two virtual machines, backend subnet. We'll just remove the load balancer. We have not seen the NAT gateway usage. We'll see that later. Let's say, oops. Right. So our setup is, so it's going to be the same. What we are doing is we are replacing the load balancer with the application gateway because we can't have both. Both are similar technologies and they're used in different scenarios. Use cases are different. Now we have the scenario here wherein we are creating, we are deploying application gateway and we are doing the routing based on the content of the website. Images and videos are being routed to different servers. So you can use Azure Portal to configure URL-based routing rules when you create an application gateway. In this tutorial, you create backend pools using the virtual machines. That's fine. We already have that. You then create routing rules that make sure web traffic arrives at the appropriate servers in the pool. Okay, so let's create the application gateway here. Right, guys, you're with me, right?
Yes.
So it starts with creating the virtual machines. We are not going to do that because we already have the virtual machines. Let's see what is different here. So we are creating the virtual machine same way in the networking, 5 backend subnet. Okay. So here we have application gateway subnet. Okay, we're creating another subnet called application gateway.
I am unable to hear your voice.
Not talking. That's why you're not hearing.
Okay.
Okay. Right. Let's
Bro,
let's do this.
can we do this live after the break?
After the break, what happened? Oh, we are almost
It's
near the
time.
break time.
12:15,
Yeah,
12:15.
that's
Yes.
fine. That's fine. We can do that after the break. Okay, let's take a break then, half an hour break, and we'll continue after that. Sure. Okay,
Okay. Okay.
get you guys. All right there.